Hey guys, welcome back to the Workplace and Apprenticeship 20 videos. In this lesson, we're going to look at lesson 4 from chapter 3, talking about volume and capacity of spheres, cones, and pyramids. Calculating the volume of cones, pyramids, and spheres is not as direct as calculating the volumes of cylinders and prisms like we looked at in last video. So to calculate the volume of these shapes, we rely on formulas that were developed and proven by mathematicians over the ages. And if you guys want to, you guys can go ahead and Google how they came up with this. But in this course, we're not going to worry about how they came up with these formulas. We're just going to trust that they work, okay? So for our first shape here, say we're looking at the volume of a cone, you would be looking at taking 1/3 of the area of the base times your height. So suppose we had a cone here, and it has a radius r and a height going from the top all the way down to the center of that cone. That there would be your height. So we're looking at 1/3 of your area of your base, which in this case is a circle. So that'd be pi r squared times your height, which is going from the top of your cone to the center. So notice here how it's not the slant height, where we might have looked at that when we're talking about surface area. The next shape that we can look at is, say, a pyramid. And we're looking at the volume of a pyramid. We're looking at taking 1/3 of the area of the base, which in this case is a square. So it might be, say, side squared. If it were a rectangle, it'd be length times width. And then times the height, and same thing again. You're going from the top of your triangle to the center of that base. So you're not looking at that slant height, you're looking at the actual base of the pyramid. Then moving on to the volume of a sphere. This is 4 divided by 3 times pi r cubed. So looking at a sphere with radius r, we go 4 divided by 3 times pi times your radius cubed. So now we're going to look at example number 2 from your notes. And here we're just going to look at the volume of cones. So a gravel pile in a maintenance yard has a diameter of 3.5 meters and a height of 1.2 meters. So part A is asking, what is the volume of gravel in the pit? So if you guys are trying to figure out what kind of shape this makes, I might always start with thinking or trying to relate, well, if you were trying to visualize what's going on here, well, I picture something kind of like an hourglass kind of happening. So say if we're looking at a hourglass, you notice that it starts in the middle and then it starts to spread out after that. So when you're asking, well, what kind of shape is that? Well, that right there is making a cone sort of shape. Okay, so our gravel pit will be very similar to, say, something of an hourglass. So what do we know? Here we know we have a diameter of your circle is equal to 3.5 meters. So it's going from one end of the circle to the other. It's 3.5 meters. And we know what the height here, going from the top down to the bottom, is 1.2 meters. So here we're dealing with a cone. So let's start with writing that volume for a cone equation. So its volume of cone is equal to 1/3 times the area of your base times your height. And as we had mentioned earlier, that is also equal to 1/3 times pi r squared times that height. So although we don't have our radius, we can easily find that from your diameter, because remember your radius is equal to half of your diameter. So just take 3.5 and divide that by 2, and we should get that our radius there is 1.75 meters. So we can plug it into our formula. So we know our radius, we know our height, so let's plug that in. So we have 1/3 times pi times your radius, which is 1.75 squared, times your height, which is 1.2. At this point here, you can plug it into your calculator and just watch out for your brackets and make sure you use the actual pi symbol in your calculator, not 3.14, or else you might have some rounding errors. And when you put that in, you should find that you have a volume of 3.85 meters cubed. So remember, watch out for those units. Here we're dealing with meters, so it's your units cubed. So it's 3.85 meters cubed. This here is also a word problem, so make sure you answer this with a sentence. So you could say the volume of the gravel pit is 3.85 meters cubed. So once you've got that written down, now we can move on to part B of this question. So part B says, what will the volume of the stockpile be with double the dimensions? Now, one thing here that might be easy to assume is that if you have double dimensions, you should have double the volume. Well, in this case here, that is actually not the case. So let's actually do the math, and let's show that even though you might have double dimensions, that doesn't mean you have double the volume. So here we need to do some calculations. So we need to figure out what our new radius will be, and we need to find out what our new height will be. So in part A, our radius was 1.75 meters, and it has double the dimensions, so we're going to multiply that by 2. And then what we find is that our new radius will be 3.5 meters, and we can do the same with our height. Our height was originally 1.2 meters, and we're going to double it, and what we should find is that we get 2.4 meters for our new height. Then we can plug this into our equation again. So the volume for the cone is equal to 1/3 times pi r squared times your height. Now let's plug in the r and the h value, and let's solve. So you have 1/3 times pi times your radius, which is 3.5 squared, multiplied by your height, which is 2.4. Plug it into your calculator and write down what you get. What you should find is that you will have a volume of 30.79 meters cubed. So as you can note, earlier in part A, our volume was 3.85 meters cubed, and now we have a volume of 30.79 meters cubed. So as you can see, even though you double dimensions, that does not mean you double the volume. So just to finish off this question, remember this is a word problem, so let's finish off with a sentence. So we could say the volume of a stockpile with double the dimensions is 30.79 meters cubed. Once you got that written down, then you've properly answered your question. You guys are ready to move on. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.